Welcome everybody to the 5th Chinese Knowledge Seekers Workshop of the Kesh Foundation. And we'll be here today. My name's Rick Kremen, your host, and we'll be here today with Mr. Kesh of the Kesh Foundation and talking with various people from the Chinese sector who are interested in the Kesh work and are showing what they're doing with experiments with CO2 GANs and various other experiments and questions that they'll have today. Okay, so let's move right along here. We've got lots to cover today, and perhaps we can talk with Mr. Kesh briefly there and move into Lisa wants to show her experiment. Mr. Kesh, are you there?
I need to translate.
Oh, okay. Thank you, Lisa.
You translate and introduce.
欢迎大家来到第5次中国网络教学今天参加网络教学的又开始先生，然后还有一些我们中国的这个对开始基金会的工作感兴趣的一些人，然后可能会介绍一些关于试验方面的问题，比如二氧化碳干丝，还有农业方面的问题今天有可能开始的时候会有Lisa 就是我介绍一下我的实验，然后还有开始先生会给我们解答问题，还有做一些其他的就是介绍。Go ahead.
Yes. As usual, good day, good evening, good morning, wherever you are. And I hope we learn, as usual, more from our Chinese colleagues with the wonderful experiments you do. Could you enlighten us? I see a lot of pictures, but please explain.
大家好，早上好，晚上好，然后欢迎大家来到这个我们网络教学。今天可能会有非常高兴有我们中国的这个人给我们讲一些这个关于他们实验的情况，所以说可能我们可以从中学到好多东西。
I think I should have said 你好 first to start with.
开始先生说从开始说你好这是我们中文的你好
Yes, likewise. Should we move into that experiment right away, Lisa, or do you want to show your GANs experiment?
Yeah, can show my
Okay, I'll move that
GANs experiment. Yeah.瑞克问我说你想展示一下就说你的这个实验的干丝实验吗？我说是的，可以。
Okay, that should be coming up there now, so go ahead.
Okay. Can we see it on the live Skype or how to see on other places?
Live stream.
Oh, live stream, okay. 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 我先说一下英文啊，中文的话，你们大家应该能看得见，我这个图片说的比较清楚，所以我就直接跟开始介绍一下英文了。My first 3 pictures are I'm trying to make making GANs use isolated method to try to isolate the electrode plates. So the first one is figure 11 is here's the GANs box, and this the black one is nano coated copper, and the other side you cannot see clear. At the right side is a zinc, and I put a cup with salty water in the middle. I try to get the gas from it, but I couldn't. And the second one, I tried this method. This is figure 12. I put the plates in the zipper bags, and in the middle, the water is salty water, but I couldn't get against either. And the third one also didn't get any gas. So these are my results. So I think is the gas probably will only created on the copper coated plates. So I made a observation about how the gas formed, and then the next pictures show how the gas are formed. The figure 1, can you see? Figure 1 is I put about like couple hours after I put the plates in, and I can see the gases formed like around the plate, and they are just floating to the center. The next one is another. The next one, the figure 2, is this is the same time. It's just another direction. So can see clearly is the gas come off the nano copper plate. And this is like 4 hours later, the figure 3. So they all floated away from the nanoplate to the center. Can see the shape. If you go compare to this one, it's like a 2 around one. Around is like a circle type on the right, and there was like a cone type was on the left. So this one is they all move to the center. And this, okay, the figure 4 is same as the figure 3. It's just a little bit clear. And I made another direction. I took a picture, and I see that like it seems that there's a field boundary in the center of the water. It's like the gas moving away from the copper coated plate, and at some place in the center, they just settle to the bottom.
Yeah, I'm showing figure 5 now, and it shows that boundary that you talk about. And it almost looks like the rib cage or vertebrae and rib cage of the human body.
Yeah, it's like that. But the right side is a little bit lines, but not the gas. The gas is on the left line. They out from there, and then they go down. They will go downward, and then we'll settle to the bottom, and then we'll. So the okay, this is the number 6. Figure 6 is this is not a sequential with the others. This is a different one. I just get another time, so I want to take another look. So this is another picture. Is shows the same. Also has when the gas moving toward the center, some point they just falling down. And I also do an experiment about the figure 7. This time I put the copper-coated plate in the middle of the box. Before was the last ones, they all hanging on the side. So this one, I took a look. The GANs forms on the both sides. It's okay. The figure 7 is the side is away from the就是face away from the zinc plate is okay. Here is the side the wall of the container, so they are forming gases here. And okay, the figure 8 is more clear. So, and on the figure 9, I showed the other side. Okay, so it's the side facing the zinc. They're also forming gas from the plate and like floating, and then will fall down. So those are my pictures, observations. So from my experiment, it seems like the gases are formed on the copper-coated plates. So it's like the nano layers are it's like the process is happened there. So, and also from my first 3 pictures shows that if they are isolated, made the insulation, so there are no gas formed. So I want to Mr. Kai to give us an explanation, and because this experiment I was thinking about, because I try to get a pure gas, pure CO2 gas. So it's like I try to isolate it several ways, but I couldn't get, and then I made the last observation.
So you managed to get your CO2 at the end?
Yeah, on those, yeah, a lot of CO2s on the bottom, those 10 pictures, those.
Are you there or have we lost it?
We're here. I guess we need to formulate a question. What specifically is your question then, Lisa? Do you have a question?
My question is like how it's like we have a salty water there. What's the I mean, what's the role of the salty water? How like each part for the electrodes and for the salty water, and how in these creating gas, what are the individual roles in this one?
Just 1 second. I'm going to explain to you. You understand?
Okay.
Just 1 second. I will explain to you in a minute. Can we open this one?
开始说你先等一下。
Background or we can see.
OK。开始先生说等一下，然后我给你解释。然后我就说，我刚才是给这个开始先生就是描述了一下这个实验嘛，然后呢，我是说这个干丝呢是在这个铜的纳米板上，然后 形成的，然后 seems like 好像是要就说会飘离出来。然后呢，我前面3个图片是我做的，这个就是利用绝缘的办法，想办法得到纯净的干丝，但是都没有。然后呢，我问开始的问题呢是说，就说我的这个比如盐水呀，还有纳米plate， 还有这个锌板，就是说这些都起了个什么作用，在这个形成干丝过程当中。
Are we there?
Yeah. Please, Mr. Cash.
Yeah. Okay. What it is, if you go back to your picture, the first picture where you saw the elements separating, the first separation, picture number 1.
OK，开始说让我们回到第一个图片，就是这种分离方式。第一个 ，OK。
If you look at it, no, this is still picture further down. Go to picture 1, very first one, very first one. Okay, go, yeah, stop there. If you look at this picture, you see that the CO2 or the GANs starts from the plate coming out. At this stage, you create CO3, not CO2. What you see at this level is a CO3. If you have calcium in your water, this will join with the calcium and become CaCO3. The reason this is CO3 is because CO3 is in structure, maggrav structure, is very much in gravitational magnetic field, the same as copper. In maggrav structure, you have 3 oxygens, which is 48, plus a carbon of 14. That gives you 62. Copper on its own is about 63. So the gravitational magnetic field in that position on the plate, near the plate, is near gravitational magnetic field of CO3, which is absorbed from the top. So the carbon comes down with the addition of the oxygen becomes CO3. Further, as it gets pulled in, if the condition is correct, then you will see CO2 and the oxygen is released as a gas, and that's sometimes you see gases on top of your plates, near your plates. So you release oxygen. This is how the plants release oxygen into the atmosphere when they absorb CO2. The condition of the nickel plate across allows the condition of the extraction or a condition that the gravitational magnetic field sits near the plate. I was explaining this yesterday to the knowledge seekers. Something which a lot of teaching has missed, and is something to go in depth, is that first of all, we know that at that point, if you do a Raman spectroscopy and you take different ganses from different positions, the ganses near the plate are CO3Ca or CaCO3, calcium, because most of the waters have calcium, so it becomes CaCO3. After the position that all the calcium atomic structure within the water are consumed for this process, then you start releasing the CO2 because oxygen will be then released as an additional element. So what happens? You have to go back into, can we have the camera on please? Then we can explain to you what it is. Yeah, it's just 1 second. We put the camera on, then maybe we can explain it on the live stream. Can we see the picture? Can you show our picture? It is on. It is on. It's just waiting for them to see it. Can you reset or try?
Can I translate it first? While Rick is loading the picture.
Just reloaded. Are we back on? Yeah, we are reloaded now. Put it back on. Yes. Yeah, we did. That was ours. That was, we switched it off. Can you see it?
Not yet. It's trying though. Just give it a moment.
Give it a kick. Armand thinks he needs a plasmatic kick. Have you seen the picture?
I've got Vince. Vince has come through, so the video is working, but it's still having a hard time coming through in your end there.
We are in Italy, so we always have to do everything with finesse. Don't close it.
No, it didn't. Okay, try again. Yeah.
OK。现在的话，他们还在调这个，就是视频，想把这个开始画图片可以给看到。
Okay, if you don't get it, we explain it. Carry on, carry on. Sorry, listen. Carry on translating.
OK，开始刚才回答我这个问题，给我解释说，他说呢，就是我们在这个第一个图，我的图1里边看到从这个就是纳米铜板上下来的，这个时候呢不是二氧化碳，这个时候呢是CO3。然后呢，因为 CO3 的话呢，跟铜的这个磁引力场呢比较接近。CO3 的话是，我看哈，它是48加上14，他说是是62，碳是应该是12啊，然后反正就是这个意思，说比较接近所以呢，就是等于是。一开始的时候是 CO3，然后呢，它会跟如果我们的水里边有钙的话，它会形成就是 CaCO3，这样，所以呢，就是说，等到就是说这个干丝往中间移动的时候呢，它会如果没有钙了的话，它会。变成CO2 干丝，这个时候会往出放氧气，这就是叶子的情况然后呢，还就是说，所以说呢，如果我们在不同的位置取这干丝的话，如果做实验测试的话，可能会东西不一样然后说。在这个说，昨天开始先生昨天说跟这寻求者们解释过，然后有一些东西呢，就说是好像就是说，没有特别仔细讲，说如果就说你把这个做光谱实验的话，可能会不同的干丝结果会不一样。然后等其他的我再继续再解释吧。然后现在等开始的这个图已经画好了。开始先生，Mr. 开始 please go ahead.
Yeah. Okay. Now it seems that we got the video on the live stream. Something which we had to, and we can we go? It's okay. See, okay, I see it here. I can adjust it. No problem. I see delayed, okay. So we'll try to explain something which, as I said, we start going more in depth, and when you do experiments like you've shown, it allows us to add to the knowledge. If you look at the box of what you have a, I have to go this way. You have a copper plate on one side, and you have a zinc plate on the other side. So in this process, on the copper plate, you have a nano material, which means now you created a free magnetic field environment. That's what the nanomaterial is. So in around this region, you created nanomagnetic field. But there are something which is very important. We explained this yesterday here. One thing is, you have in this setup a copper. In this setup, you have a zinc. In this setup, you have the salt, you have the hydrogen, you have the oxygen, and whatever minerals are in the water you carry. So the total gravitational magnetic field, balanced total gravitational magnetic field of these elements in this environment create a magnet which is the gravitational magnetic field somewhere in this area, which gets extended to of CO2. So what you create is a magnetic environmental area of CO2. That, as we showed it before, if these are magnets, you can see we added a plastic, the white one here. You can see we have a black one here, and we have another magnet. The only way that the CO2, carbon on its own, and oxygen, which is a common denominator between water and the air above, can be attracted if you create the gravitational magnetic field of the CO2. So what happened in this process, the carbon and oxygen are free elements on the top, and when the gravitational magnetic field of the water, environment of the water, becomes equal to CO2, the two merge and you get the CO2 in your system. Don't forget the structure. Similar magnetic gravitational fields attract or repulse. Iron is magnetic in the environment of this planet at the given present gravitational magnetic field, and we detect it as magnet. And we call it a magnetic, and we always associate with iron. As now we understand the gas structure, now we have learned to create in different environments that whatever we need becomes magnetic environment. This is a change from matter to creative condition of gravitational magnetic field. So what happens is that in this environment, and you see the shape of it, the gravitational magnetic field in this environment is equal to CO2. But initially, because of the strength of the gravitational magnetic field in this zone, you have the CO2. So you have the release of, creation of, absorption of CO3 near the plate. As they take shape, the first elements are matter. So immediately they fall due to their mass, they fall to the bottom. And then follows as the environment changes to CO2 strength. Now the CO2 in the process with the CO3 or on its own gaining mass falls to the bottom of the container. So when you put a copper on the other side, on this side, then you create a different gravitational magnetic field environment in this area, which is, if you like it, is copper. By changing the plate from zinc to copper, you change the environment gravitational magnetic field. And in this process, because you create the gravitational magnetic field of the copper, then you find out that your copper layers, nanolayers, get released, and then they become GaNs, and at the same time, because they are plasmatic, they attach themselves to the oxygen, and then you get CuO, CO2, and what the rest. So now this is where it changes, and that's why you see the process of GaNs production. And that's why you can try different elements. And so from now on, we create an environment, a condition, that in this condition, the environment can be gravitational magnetic field of any element we like it to be. And now this is the process of research, finding out what gives what element. That's why all of you use zinc and copper, you get CO2 with the salt. You use copper and copper, you get CO2. You use, what do you call it, copper and lead, you get different things. And then it ends up with all sorts of materials and gases. Because all you do, you create an environment in this section of the container that leads to creation of gravitational magnetic field of an entity, and if that entity is within the vicinity, will be attracted to the environment. So now you create a magnet of CO2, then you create a magnet of CO. Yesterday, here, going through the same subject, I explained, everyone is following the CO2 production or the plates and salt. Has anybody tried salt and sugar? Or just sugar instead of the salt? So now we have experiments set up here on the table where we have a nanocopper, yeah? Nanocopper, copper, and nanocopper zinc. One with sugar and one with sugar and salt.
No, one with sugar and one with sugar and gas.
Okay, one with sugar
and
salt, and one sugar and gas.
Sugar, gas,
And salt. So we're trying to create a new environment to see what we get. We know what we're going to get from the environment of the creation of CO2 through presence of salt. And in this process, we get a CO2, which we all have done. But by adding a factor of the sugar to it, we introduced a false CH bond, which is very much in the form of CH3, but composite, much different chemical chain of events. And now we want to see if the CO2, which we all have created, which has led to the creation of fat on the top. Arman has got his mixer in his hand, he's trying to do it. Once we finish, we'll see the fat on the top that we all have seen. That in the presence of the fat amino acid on the top, in the presence of CO2 as a gas, and in the presence of the CH3 or CH bond, whatever it could be, we can lead to creation of sustainable life. What this means is that now you have an amino acid which has the oxygen bond and now has received the hydrogen bond as well. So the gravitational magnetic field holds the two, the communication line holds there, and the CH3 or a sugar bond become the energy supplier through the centralization of the nanomaterial of nitrogen. So the circle and the whole cycle of creation of life, sustaining it and replicating it, we have started today or yesterday. So we want to see an Armand is ready with his mixer to be like a wind, twisting the amino acid inside to mix with the CO2 and with the sugar, which leads to production replication of life. Then in the coming time, we add iron to it, and then we add copper oxide to it, or magnesium, and then we'll see how the color changes, and then how we see the process. As I said, we've gone into the next phase of the development and understanding. So, in fact, it's not just a copper plate, nano-coated, and a zinc plate, which extract or creates the environment of CO2. Because you have a liquid condition of the water, of the sodium, and on top of it the chlor, which is part of the salt which is inside, plus if you have calcium, this totality of all these materials, elements, inside this containment creates a CO2 gravitational magnetic field effect that in that process allows the carbon to be extracted, and in being extracted and being in composition with the oxygen in the air to create a CO3, and in most of the cases connecting to any other element, and after that is finished you will see the production of CO2. In fact, if you observe all the materials at the bottom of your bucket, you see like a bone structure, white, like a flakes of white. These are all CaCO3, and this is kind of the composition of your own bone, which is connected to the calcium in the salt of the body of the man. So if you see flakes at the bottom or pieces of solid, this is a CaCO3, and we've seen this with Raman spectroscopy and infrared spectroscopy. So that's the process. It's not how the elements are separated from the wall. The elements are separated because on the interface of the nano layer, you create a gravitational magnetic field, which a copper is 63, and then you have carbon plus 3 oxygen, which is 62. Near enough gravitational, taking into account all sorts of other matter elements inside, creates a magnet, which this magnet then creates the environment for a CO2, and that's how you extract CO2 from the environment. This is a new understanding of by creating environment to create magnetic fields, and not by having the elements like iron only. So you can create magnets for oxygen, you can create magnets for plutonium, you can create magnets for any element or composite in the universe. And this is how, if you understood this, this is how you create condition of gravitational magnetic field of the destination, and you get attracted or repelled to it. It's not just looking at it in the material production, you have to look at totality, what it leads to. I was explaining this morning to the knowledge seekers a very simple phenomenon. As I've said this before, we started with matter, showing you how to make the material. Then we showed you how to create a control. Now we showed you creation of materials. Then now you understand by creating and controlling them, you have your what do you call it, star formation. Then now, up to now, you've learned the control, or you're trying to learn the control. You need to have the next step, which then it gives you the ability to control, to fly, to find condition and produce the lift or energy which you are looking for. In fact, if you look at the environment of the star formation and the free plasma, In that free plasma, what you're trying to do is to create exactly the condition you created in the center of the water. Here, you created the gravitational magnetic field of CO2, you attracted CO2. In your star formation in the free plasma, you try to create the environmental gravitational field of the planet or the Earth to repel or attracted to. So, in a way, there is no difference between your water container and your star formation system. In the CO2 sets, it's a predetermined, it's been tested, so you achieve it. In the what you call star formation, you are looking for that imaginary plasma that, in respect to its environment, will dictate its position. Here, carbon and oxygen in the environment above the pot were conditioned to the gravitational magnetic field of the carbon CO2, and then so it got attracted to it. So now you're trying now to be the gases above the container to be attracted by the Earth or be repelled by it. And thank you very much for such a clear pictures, because now you can explain it. I hope I was clear enough. Now you can translate.
Okay. Okay, thank you very much.
You can use, tell me, I'll put my pictures up. I'll put the pictures up that you can explain. Okay?
Okay.我现在I will give a quick translate, and then later we'll translate in detail. So, 凯始先生给我们讲，他说，这个照片呢，是这样子的，他是说，我们是现在有一个这个纳米的铜的这个板，这边是有个锌板，然后呢，再加上这些个盐水呀，还有里面的矿物质，所有这些东西是组成了一个长体，这个就是跟一个磁铁一样，就是类似于磁铁，那么呢，它就会吸引二氧化碳或者吸引碳跟氧进来，然后组成二氧化碳。然后呢，在这个纳米铜的这个地方，它会就是说，因为这个氧化铜的这个和这个CO3的话是一样的，这个接近于原子量一样，就是说场一样，所以在那里会制造出这个CO3，然后呢，那么就是说，如果这里边有钙的话呢，可能会形成就是说它类似于CaCO3这样的结构，还有呢，就是说我看看，再往下看就是说，中间还讲到了一个，就是说我们地球上，就是我们这个磁铁呢，为什么就说这个磁体吸引铁呢？就是因为在这个地球的这个磁引力场里边，这个铁呢具有这个跟这个磁场具有这个磁性，所以呢就是正好是这个环境，所以呢铁呢表现为就是说对磁会有吸引，这个就是说我们所有的这些呢都是要就说你创造了一个条件，一个场体，那么这个场体呢就可以吸引不同的东西，后面呢他又讲了，因为那块我断线了，就说没听太清楚是怎么回事，就说如果加一个糖的话，那么呢我们有二氧化碳的话，加了糖以后，我们会做出这种就会形成一个场，然后就会制造出脂肪酸，就是说氨基酸在这个上层。我再看一下这样呢，然后还有呢，就是说，你的这个二氧化碳的话是从这个就是CO3的话是从那个板子下来以后会往中间走，走到中间呢，它就会那个场体它就会变成 CO2，就是二氧化碳干丝就会沉到底下。他说是这个样子的，因为那个场的变化，然后还有说，如果你要是有钙的话呢，你可能会在井底下看见这个碎屑，就是可能是我们的骨头，就是类似的这种结构。然后最后呢，他又讲到我们的星星造型和这个 就说我们这个干丝盒子呢，实际上是一样子的。我们这个干丝盒子的话，你可以吸收不同，就是说组成不同条件可以吸收不同东西，对不同东西会形成磁体。那么我们这个星星造型呢，就是开始就说讲了一下，那么中间呢是有一个自由等离子体，那么自由等离子体呢，你可以和其他的，就说在磁场相匹配的情况下会排斥或者吸引。那么你如果造一个，就说类似和地球磁场相匹配的，那么可以吸引地球，也可以排斥地球，就说你就可以达到飞升和降落的目的，或者你就可以造物。就先解释这么多吧，然后因为时间也蛮紧的，我们看看再往下能不能进行其他的问题。OK，Mr. Cash。
We have a request from Vince. Can we expound on the math of that list of materials you have on the screen for CO2? Or we can move to Jan and his demo of the CO2 GANs in gardening.
Oh, I have another question. It's not a question. It's like a suggestion. When we have, I was thinking because when we have like using in the reactors, we treated you use GANs to treating seeds. We need like how much GANs we used. And I come up with this method. You can, because the GANs sometimes they get condensed when you put it in the bottle, and after like a month, it will like, shrink to half of the volume. So if you say 10 milliliters, 10 mils of GANs, sometimes it's maybe another time maybe only half of it. So I'm thinking like maybe you shake the GANs with the water, and then make it homogeneous, and then you take like 10 mils into the petri dish and let it dry, so you can weight it. So in this case, you can get the concentration of the GANs. It's like you weight a petri dish first, and then you put like 10 mils of the GANs liquid into it, and then you dry it, and then you get the solid part of the GANs, and you get a weight, so you know how much GANs in those liquid. So in this way, you can get the percentage. It's like a solution, like a metal solution, so you can get a percentage. Otherwise, it's hard to say like 40% or 20% of GANs. Understand?
Did we lose Mr. Cash? Still see the video.
I think his audio might be turned off.
I've been put on the silent without. They silent me. Marco moves around and just puts things on and off. So he decided I better be silent. So what it is, as I was saying, that I listened to what you said, and it goes back to what we said some times ago. As the institute is getting established, and one of the first jobs that we will take up is setting up standards for measurements of all sorts of things. One is this measurement of the weight of the GANs, the measurement of the magnetic field of different matters, that scales for measuring magnetic gravitational fields. These all be done, and then what you suggested is part of that structure. We have to standardize that within 10 millimeter, how much, what do you call it, GANs will exist, or it is, and then what you get a concentration of. This is part of the process. We are pioneers in this, so we have to set the standard, and the Institute is a good place as an institute to set the standard for the GANs and measurements of all sorts of macros. The institute, by the way, it'll be called, it's been registered at Keshe Foundation Spaceship Institute. So we work under that banner. So we set up the standards for measurements of the gravitational magnetic field and what they call space positioning. Okay, next question. Can we have, or do we have anything to do with the ants from the Chinese community?
I do have a report on the ants. The folks there aren't able to be on audio, but I've got a little report that I can give. Okay, well, it goes. Maybe I'll show the little ants video that we had before. Let me just get it up here. There it is.
Huh?
And I'll here's the report. The report on the ants. Just get it up here. Soleil says, for the ants, here are my observations. I did so far 5 tests with 3 different colonies. The ants show immediate interest. They touch and consume the GANs. They do not die or get harmed. Also, every individual ant starts doing the same thing when coming in contact with the GANs. They start throwing all types of material which are available around them inside the containers of GANs until it's filled up completely. After the container is guarded by 1 ant at all times. And then they start consuming the material which has been through inside little by little. All tests have been done with salt-free CO2 GANs. Also did tests colonies with container with just water in the container. Ants don't show the same behavior. The container will be left alone. So it wasn't the water, it's the GANs that they're interested in. Which is interesting.
Can we have Soil online? Because there's a question to ask.
He's on the live stream. If he can answer in the live stream, that could work. Or he said he was going to be on the live stream. I'm not clear if he actually is.
Okay. Now, what is important? What is interesting to know is that if the ants consume the CO2 or consume the materials they put in the CO2 container.
Well, he does say that they start consuming the material little by little, and they guard the container, so they must value it pretty much.
I think what we need to know is that do they actually consume the CO2, and then when they finish consuming, they have no more what I call hunger for it. Then they put the material to bury it, and then they eat what is on top of it, which means the GANs state releases the energy which they're expecting, or they look for. If you could have a full video of this, it would be very interesting. So the ants don't die, there is no changes in them.
Sorry, that's what he says here. He says they have immediate interest, they do not die or get harmed, and they guard the container when they I'm not quite clear on what he says. They start throwing all types of material which are available around them inside the containers of GANs until it's filled up completely. I guess, like you're saying, they put the material on top of the GANs maybe to bury it.
And then they start consuming the material. This is what I understand. which they put on top of the GANs.
Maybe they put the.
Yes, that does sound like that might be happening. I'm not sure what material. I know they do have this sort of jelly-like substance that they use for the ants to live in, and maybe that's some of the stuff they're talking about.
Okay, we need Sohail to explain to us.
Yes, we do, and I see that it's been asked in the chat if he's there, and apparently he's not responding. So I think we're having trouble with that.
I know a guy who's done his thesis on ant colonies, so we can put him to see and check how it is the behavior. He's done a thesis on the behavior of ants, ant colonies. So I'll put him in touch with Sohail.
Yeah, it'll be interesting to get more on that.
Yeah.
Okay.
What's the next question?
Well, we did have a question here that gets a little involved, but
I think we let Lisa to translate.
Yes, thank you.
We forgot about that.
OK，刚才开始先生问一下关于那个就是蚂蚁的那个试验，然后呢，瑞克就念了一下这个实验报告。这个实验是由 Sohail 做的，然后但是 Sohail 不在线，所以也不能问问题。就是开始后来跟瑞克就是讨论了一下这个案子到底是怎么回事儿所以我们可能今天也没有多少时间了，再看看他们怎么安排吧，然后基本上可能就这些。回头的话呢，我们再仔细把这个再翻译一下，因为下面马上要就是说健康讲座了，所以我们基本上就是说可能今天就只能问这么多了。I was saying that we almost time to finish, so I will translate more detail later. So
okay, well, we have an hour or an hour and a half today.
Well, technically we only have an hour, unless we want to get into Elia's
Let's go half an hour extra, and then we can go to Elias, because the whole question we answered only one question, which was from Lisa, but I think it was important to go into detail about it. That explains a lot of things about the whole work. That's the foundation of the work. What's this picture we see?
Okay, can someone let Elia know about that? That would be good. Amrock probably will. Okay, what we have here is a question from She. How's it pronounced again?
She, yes.
Okay.
She.
Which says, until now, knowledge seekers have developed various kinds of reactors, but none of them have been able to lift. According to what Mr. Kesh said in Knowledge Seeker workshops, you will give the ignition key to governments, and governments will make the decision when and how to achieve lift. I have a question to ask whether the ignition key is the process of scintillation, as referred to in your patent. It is a controllable chain of energy transfers, and whether it could be completed in the following way. And then he has this picture of the what appears to be liquid helium on the left with an alpha beta source, and having that piped into a vacuum chamber with hydrogen in the middle.
This is already in the patent. Centralization is part of the patent. We already explained that. But that is for the gas.
But centralization is used for the gas, to create the gas into the GAN state. It's not, if we already have a GANs in a GAN state, we shouldn't need the nuclear aspect of things to kickstart it in terms. We have to find a different way. I think we talked about that on the last workshop.
But does it turn the gas into a GAN state? Is that the purpose of the scintillation?
Let me explain. Somehow the questions are coming in a strange way. We were discussing this morning here on the table. If you put the camera on, we can show you in a minute. Where do I get the camera? The whole process. Where are the papers from this morning? I put them away. We have some, one-to-one teachings here in sometimes because it's easier to do it. This way I can explain it much easier. This is from yesterday. Where is CO2? Yeah, this is from the sodium combination yesterday. Today's big paper, one of the papers is here. It doesn't matter. It's okay. Yeah. Yeah, is that better? Okay. So what happened? What we were trying to explain is there. It's the top page. The top page is part of it. It's the, I have the rest of it here somewhere. Yeah, here a minute. This is the process that we're talking about. What happened when you look at the centralization and hydrogen? The whole process, as we discussed in the last workshop. I'll leave it with you. As we discussed in the last workshop, is very much, yes, that's the one here. If you look at the whole structure of the work we've done up to now, is to achieve atomic hydrogen of 2. What this means, atomic hydrogen which has a proton and has a neutron with 1 electron, which this hydrogen is the most stable hydrogen element which you can ever find. The H with a single proton and an electron, in time, because the loss is different, the proton will become behaving like a nitrogen and it'll divide. So you get submatter elements. With the hydrogen, with 1 proton and 1 neutron, you have the stability of twinity. So what happens is that in this process, you have an element which hardly ever divide, and depends on one condition you put on it, it'll behave as a matter, as a GANs, or as totally as a gas. But the whole 3 states in this case, because of the behavior of the hydrogen, tends up to be the behavior of GANs, even if it shows itself as matter. In the process of your gas systems, where you have the helium, what you have, if you look at it, you have 2 hydrogens of 2. You have 2 neutrons, and you have 2 protons, with each one carrying their own electron. So the process of centralization is to create GANs atomic structure or atomic hydrogen 2. This is why you use GANs. This is why in the system, if you could able to look at the gas reactors which we have in the first lab, the center is still hollow, the same as what you see as the hollow balls in your course. Because now the nano state of hydrogen 2 is in a gas state too. So centralization we use in the gas state is to achieve the state of H2 that allows us to have the condition that we can deal with a stable element which in the long run you can make a combination of these H2s in a gas state that if you add them together, you can have carbon, you can have oxygen, you can have any combination. Because these are of the same strength, common denominator, it's very easy to make matters with the base. How much of it you want to add? If you have a copper and you want to make it into gold, you have to add and come into what you call the plasmatic fusion. But when you have a common denominator, the collective gravitational magnetic field of the same, because it's a single unit, will allow you to produce the behavior gravitational magnetic field of any element you like in the universe that you lead to creation of the matter you want. That's why we do that in the gas reactors. We do the same back in the, what do you call it, as we said, with the materials in respect to gas state 2. So all we do, as we saw in the first explanation, that we created the environment of CO2, so we extracted CO2 from the environment. Now we create environment. If you remember what I'm going to explain, the magnetic pressure, magnetic gravitational plasmatic pressure, you create a conditional pressure that allows that the element you like, its gravitational magnetic field, not by fusion, by cohesion, to come into existence. Which means by their coming together, as they're all plasmatic and is a single state, the interaction of the gravitational magnetic field gives the identity of the matter, so you can produce the matter by conversion or by attraction of the fields towards it. So you put the compression attraction of, let's say, copper in one corner of your pot, and then you start collecting fields which they collectively become that strength, and you collect your copper. If you go back into the explanation where I explained you have a 3 center cores and you put the 3 outer cores, in these cores you create this magnetic field. In a way, that's why we do centralization. Then you can create with the H2 the exact gravitational magnetic field of any point of destination. It's very easy, it's very rapid. At the moment, most of the materials we have is composite. This, there is no composition, but it's a cohesion of the gravitational magnetic field, which gives the entity as one. This is why we, in the gas-filled reactors, in the very near future, when we set up the institute, you will meet a scientist who's specialized with this. He has achieved levitation through the same process, but through sodium and mercury. And now he has seen what we do, and he says now he found a way to do it. And he's joining us. He's a professor, he's a doctor. He's joining the foundation to teach how you can use the materials, because he's done the 30,000 RPM into a small rotation, and you can achieve more lift and motion. The whole purpose of the centralization was to create the atomic hydrogen 2. But in a gas state, we need to access it directly, and that's part of the structure. You want to translate?
Okay, probably don't have time to translate. Just roughly translate a little bit. 这个是史先生给问的这个问题，就是大家可以到这个什么上，就是我们的论坛上，它有一个帖子跟贴了这个问题，就是关于我们的反应器说从来都没有飞升，说开始原先讲过需要这个一个就是说 synchronization。这个词怎么翻啊？不知道就说要类似于离子化的这种，然后开始说我们这个气体的反应器做呢，实际上是要得到氘，就是氢二。因为氢二的话表现呢，可以是干丝，那个是点火装置，就是说可以表现为干丝，也可以表现为就是这种原子结构，也可以表现为物质，所以说这个氢二的话呢是很重要的，然后呢。后来又讲到说，可能有一个博士的话，他原来用其他的元素达到这种效果，现在呢，他可能马上会加入到基金会，可能会就是说做一个系统完成飞升。基本上就是这样子的，所以开始今天强调了一个这个氢二的话呢，就是它不叫氢了，就是我们的氘是一个特别重要的金属元素。我猜想是，就是说上次讲座里提到的这个元素可以造任何物质，应该是这个氘。OK，thank you。Mr. Cash, so this is H2 is the element you were talking about the last workshop? Because last workshop you said one element you can use it to create anything you want. Is this element?
Can't hear you, Mr. Kesh. Your sound's off, I think.
I was controlled again.
There you are.
I put the microphone on off. Yeah. Yes, this you are correct. This is what we call deuterium, but I call it H2 because it's straight away it means it has a proton and electron. The whole structure is stable, and you can use it for any purpose in the universe. And that's what we explained last week.
Okay, thank you.
I tell you something, we're just talking to Armin. He said it is spooky. We spoke about two things, and there are two questions coming on the table in what we spoke yesterday and today. And I said, you don't know what I know. I know what's the next question too, but we can carry on. Because
Okay.
we got all the teaching papers of yesterday and today in front of us, and even now you see it all. This is the if you can see the picture. I don't know if it's available to you. Can you see the picture on the table?
Yes.
Yeah. If you look at it, this is the H2, which we were talking about. You can see this is the discussion of this morning, and the discussion of yesterday was, as we showed you some papers, was about the creation of the, what do you call it, CO2 in the atom. So it's not coincidence. These are the teaching of the yesterday, and we were talking about exactly what you asked. You can see the picture of the CO2 and how it's created, and creation of, as I explained to you, the zinc, the sodium and oxygen in the container. So we already knew what questions you're going to have today on the table, and it was discussed here. So we had a rehearsal.
Do you want to announce the next question then?
Then it becomes very spooky.
Well, we do have a spooky question here if we want to bring that one up. But I want to also acknowledge Jan because he's has this presentation he'd like to do. But we've only got maybe 15 minutes left. So how do you think we should proceed?
Let him do it. Let him proceed. Let him see, and then we start at 3:30 with Elia. Can we go? And yeah.
Okay. About let me see.
What is the next one, please?
Okay, we've got
Experimental
the
one.
experiment number 1 with CO2 GANs, right? Is that what you want, Lisa?
Yeah.
And we can get
Experiment one. Let me see. Let me see. Experiment. Okay. Yeah. Show the. Let me see. Should be. Okay. The other one. Experiment 2. Show that picture.
Okay.
I need to check what's in there. Yeah.
Just a second here. Just have to get that one up. Okay, it's coming up on live stream.
I can explain first. Miss Yan did some CO2 gas treatment for the strawberry seeds, and the seeds they treated 2 methods. One is use gas treated first, 就是and then he used to light it in outside to give a cold treatment, so break the dormancy. And another one, when he bring back the seeds, put in the to let it germinate. He found some seeds was has germs on it, so he want to he treated with GANs again, and so the germs still. The second day the germs appears again, so he want to know whether the GANs cannot kill the germs.
Depends, I think, what gas he uses, huh?
He uses CO2.
Ask him to use the copper oxide.
Okay, thank you.
And let us know, because when you have a stronger field, it's very much like a cancer, because the what you call the magnetic gravitational field of the stronger will extract the energy from it. This is one of the processes we use for different cases. And for those who, because Armin just walked in with something and he said, can I use this? This goes back to what we talked about, or Rick and Vince in the workshop last week. How to make a gravitational magnetic pumps pressure, that you can increase the pressure on your, what do you call it, on the tubes or on your cores. The only way you can create motion, circulation, and compression on the GANs is when you use a higher strength gravitational magnetic field. Which means it very much, if you understand the blood pressure, it works the same way. What you call a blood pressure is exactly what the scientists look for, our knowledge seekers look for, how to create plasmatic pressure, that it can convert one matter to another. So the same goes with the state of the germ. Germ is a composite, so he has to find a gravitational magnetic field. The reason your CO2 disappeared or the germ disappeared and appeared again, your CO2 became the food, like for the ants. So the transition point, you don't see, and it comes back again. So you have to create a gravitational magnetic field environment for the germ, that the germ becomes the food, not your CO2. And if you understand this process, then everything is what do you call it? Is eradicable. You can eradicate everything. You don't need to use bacteria or whatever. You just wash your material with a higher strength or pass it through the higher strength, and what you don't want will be absorbed by it or become the food for the energy part of it, or get attracted to in the case of the GANs. So you remove it. Ask him to use a CH, because if it's a bacteria or it has a what you call amino acid bond, then the amino acid bond, you have a 14, 16, 12, and 1. So that's 30, that's 43. So if he uses a copper oxide, he passes, the strength is higher than the whatever could be the combination of the amino acid of the, what do you call it, the bacteria or the whatever fungus. But CO2 is much lower, so CO2 it literally is getting eaten up, so the power is higher than, what do you call it, CO2. CO2 is 44. So it's not strong enough to eat up or absorb energy from. So you need to use a copper oxide, which is 63 plus another 32, which is around about 95. Then you can extract. You don't extract, you take energy from the, what do you call it, the bonding of the bacteria, and you'll let us know the result. You want to translate?
Yeah, OK。开始先生解释说，这个因为二氧化碳的话，它的这个能量强度和这个细菌的氨基酸强度差不多，比较弱，所以它就是说不会杀细菌，它有可能成为这个细菌的这个食物。说如果要是处理的话，那他建议小严的话，可以用氧化铜来处理这个关于菌的这个问题。那么我不知道小严有其他的问题吗？应该可以说话吧，他在这里。
哎，我在，大姐，还有一个问题就是说，那个浓度的问题啊，就是不同的干丝溶液的浓度是否对于这个种子浸泡时的影响不大，而跟浸泡时间有关系。比如说不同浓度的干丝溶液，是不是对于这个？
我知道你的问题。对，但是你这问题是，我给你问一下吧。Mr. Kaiser, he want to know another question because in his experiment he observed that the concentration of the GANs when treating the seeds doesn't different much, but the time is more have more effect on the seed.
Yes, we explained that before, that in the seed trials we done, the duration of soaking has a direct effect. If you go back to the other teachings, we already explained this. We know this because what it does actually, like the time you put your copper plates to nanocoat and they expand, the same thing happens with the seed. When you put the seed in the CO2 mix, the magnetic field of the CO2 has to penetrate layer by layer of the protein of the seed. So if you have more time in it, you penetrate more. It's a reverse of building a nanolayer on the seed. You go internally and you change the structure of the seed from outside in. And if you take what you call every outer layer is the latest lifestyle for the seed. And if you take most of the lifestyle away, you go to the origin, which is grass. And that's what happens. That's why time is a factor, because it's a magnetic field growth or conversion. And then because it's a CO2 and you have a seed, we explained the paper, I think it's already completed, should be done by the foundation, will be released, the agricultural paper. And you see in there time, there is a time, soaking time has a factor. And the reason for it is the CO2 is magnetic field matter, and the matter or the skin of the, or the material of the seed carry protein bond. Doesn't matter what they are, they have some sort of protein, but they have a magnetic field connection. And this CO2 penetrates deeper and deeper. In a way, makes a nanolayer internally in the seed. And then as you convert matter into the GANs nanolayer, now the information will change to lead to the mutation of the seed is not there anymore. So the seed can only grow till the layer where the mutation has not been touched. So if you leave the seed long enough, you go to the point of the grass. So the wheat becomes, because you cannot go any further to touch this origin. And that's why, if you remember with all my talk in past few weeks, we say goodbye to all the work which Monsanto has done. Because all you do, Monsanto has changed the outer layer, the latest cycle of life of the seed. With nano GANs material which you put in, you neutralize that point. So the mutation which has been put on to control is gone. That's why the timing is essential. It depends how much you seed, depends on the strength of the compactness of the seed, or how soft the seed is. The softer the seed, the less time to reach the point of balance or the origin. If they leave the seed, let's say, for a week or so in the GANs, and then plant it, most probably we see the original strawberry ever created at the origin, which became the mutation has led us to the present strawberry, which is using. Do you want to translate?
Yes, OK，开始先生才给你解释了一下啊，这个就是说这个是确实是时间比较重要，然后因为是你这个做处理的时候，实际上是就是说你这个溶液会往里走嘛，然后就会处理不同的纳米层，然后就会把它都变成物质，然后呢就说你时间长的话就会进入到里边会改变的更多，如果最外边的话呢会改变的少，所以跟时间有关。然后就说这样的话呢，如果你要是处理一下的话呢，会把孟山都的这个就是说给处理掉，因为它只是改了最外面。如果你要是处理足长的话，那么就会就完全就会变成就是说最早的最原始的那个状态了。基本上就是这样，然后回头我们再仔细翻译一下，因为时间也不多了，剩1分钟了那就基本上可能就这样，因为我们延长了半小时开始先生说希望我们这个能延长嘛，所以后来跟那个瑞克他们还有 Amrak 讨论，决定延长了半小时，所以我们现在进行到10点半OK。
We're pretty much short on time here for the last minute, or this should be the end of the workshop here. What should we do? We do have more questions, but we can carry them on until the next time.
We switch to medical because there are people who just go for the medical. Thank you very much, Lisa. We extremely thank all the Chinese community for their work and effort. And I hope we can extend these times to a regular basis and one every other week.
Okay. Yeah, thank you very much too. Thank you, Mr. Cash. Thank you, Rick and Wins and other people. So,
yes, and thanks to Jan and Lisa and the others who participated, and Max who participated in today's workshop.
Thank you indeed. Bye. Thank you. Bye-bye. We'll switch over to the medical.
Yes, we'll switch over to the health workshop. Okay, let me just...
Thank you. Bye-bye.
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 And so ends the Chinese Knowledge Seekers Workshop for today. Thank you everybody for attending.
Thank you，感谢大家，再见。